This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's episode, number one, we've got a great friend of Uptime coming on the show, Morten Handberg, who is the Chief Blade Specialist from Wind Power Lab. He will be joining us to talk about fatigue issues in wind turbine blades. So really deep dive on that. We haven't talked much about that on the podcast yet. So we're excited to talk about cracks and fatigue and loading and all this good stuff with blades. So look for that in about 20 minutes. First, we're going to talk about GE teaming up with GM on rare earth magnets. Obviously, those are needed for motors, nacelles, etc. So two big companies teaming up to do some of that mining and some of that legwork. We'll talk about the largest subsea cable, which is now operating 450 miles long, crazy long. We'll talk about Vestas. They're installing their V236 15 megawatt at the Oosterøld test facility in Denmark. And also some more news from Vestas, one of their executives talking about, this race with wind turbines getting bigger and bigger and some of the costs and potential difficulties about that in the future. And lastly, we'll chat a little bit about a consortium led by Orbital Marine, which is the maker of the Orbital O2, a 2 megawatt tidal power machine, which we had covered about 6 months ago. So we'll talk a little bit about tidal power towards the end. So before we get going, make sure you subscribe in the show notes of today's podcast to Uptime Tech News and to Rosemary Barnes' YouTube channel. You'll find both in the links in the description below. Remember, you'll just get an update from us if you sign up for Uptime Tech News, along with other news from around the web. So first off, let's talk about GE and GM. They are obviously two big American companies, and they are trying to figure out how they can make sure this supply chain of heavy and light rare earth magnets and materials will be available to them for years to come. Doing this forecasting is important work. Alan, what sticks out to you? Why do you feel like these two, besides the short GE, GM, maybe like a GR, they can get like a GT to their little club. Besides the names, what sticks out to you? Why are these two companies going to be good partners in this?
Well, they're hedging their bets is what they're doing at the moment because they're concerned about China and trade with China being constricted and the economic situation that's happening in China at the moment involving real estate. And so a lot of rare earth minerals come from Asia, China in particular. And there's deep concern in the United States that as our technology moves forward and we get more into the electric motor world, that we're going to need more rare earth materials that are in America, in Australia, and other places on the planet. But the investment to go get them can be rather large. And if we're thinking about U.S. independence from some key economic players in the world today, they're going to have to find U.S. sources or Canadian sources to go after those minerals. So I think this makes sense. What's interesting about it is where's Tesla? Like GM must not be friendly with Tesla at all, and GE must not be getting along with Tesla because you think Tesla has this kind of figured out at the moment. So now Tesla's kind of pushed to the side, and really big industrial players are going after those rare earth minerals. And if you can corner that market, you can really put stress on a Tesla. So there's a lot to this particular agreement, I think. And Rosemary, do you see the same thing? I know Australia is full of great minerals. Do you have the same issue there?
Yeah, I mean, we don't manufacture many of the things that need rare earth minerals. So I think for Australia, it's more relevant from we want to be a supplier side of it. But I think that I'm no expert on rare earth minerals, but I am very interested in sustainable mining in general. And I think that the reason why China produces, I think it's still more than half of the world's rare earth minerals. And I think it's because it's so far so environmentally damaging to process them or to mine them and process them. I know that the, old mines that have produced these minerals are really, really degraded now. Those areas, often you can't grow crops in the area anymore. I think the wastewater is full of high levels of radioactive, high concentrations of radioactive waste. And I think that the rest of the world has been happy to let China, go for it because they don't want to deal with that. So now I do see that this is a good opportunity, really, while everyone's worried about trade. And I know China threatened to stop supplying certain countries at some point. It's a good opportunity to clean this up to the point where we can produce them anywhere. Because, despite the name, they're not rare. They're everywhere, right? Every country probably has the capability to produce some if they were happy to, make it work within the environmental constraints. So, yeah, I think it's going to be an opportunity, and I think it's past time that we, recognize the reality of these critical minerals and, started to bring them into the 21st century.
Yeah, and I think that's, we've obviously had supply chain issues this past year with COVID. And I don't know that what the source of all of those is, but, like the chip and the semiconductor shortage has really hurt the auto industry in general. And I think that's probably been maybe the pinch that a lot of companies have needed to say, well, hey, we probably need to evaluate some of the other supply chain items that could potentially bite us in the future, whether it's 5-10 years down the road, and start to get some of that infrastructure created. Because obviously mining operations are complicated, right? And like you said, getting something from one country that might not be friendly, or maybe they're friendly with us today, but might not be friendly tomorrow. You can't necessarily predict those foreign relations. And if they're to break down, what happens to a company and what happens to a supply chain. So yeah, I think this makes a lot of sense. I think both of you brought up really good points that this is a really important future forecasting event, because the whole electric car and these nacelles, they require so many new materials that we didn't need quite en masse in previous years. So moving on to other gigantic operations, the world's longest undersea electric cable, Britain's National Grid, their North Sea Link, is now up and running. And this is 450 miles underwater, and it literally breaks my brain thinking about how we humans did that. Rosemary, how did this happen? This North Sea Link is just an incredible endeavor. It's super impressive, but I just don't understand how we humans pulled this off.
I don't know. I guess I'm not so surprised because it's more of like an incremental thing. People have been installing subsea cables. They're gradually getting longer. They're gradually getting thicker. So what actually stuck out to me about this one is that this is currently the world's longest, 724 kilometers for those who don't speak US units. And I know that the Sun Cable project that they're planning, I'm keeping an eye on this one, this Australian one that connects Darwin to Singapore. And that's the plan is that that's going to be a 3.2 gigawatt cable. And the subsea portion of that is 4,200 kilometers long, or that's its current length. It's kind of gradually getting longer as they survey the seafloor more and find, like a realistic path rather than just drawing a straight line on a map. So yeah, this current longest one, it didn't shock me in its length so much as really highlight how huge the future plans are, and maybe make me question whether or not this is something that's likely to happen in the near term, that we can all of a sudden go 5 times longer. So yeah, but I think the potential, we need way more of these as we get more variable renewables. You need to connect up different geographies where, in Norway, it's good because they've got so much hydro, which you can control when you start and stop it. But, even connecting areas with different wind systems, east to west, to get, a longer duration of solar, that sort of thing. I think we're going to need a lot more of it. So it is really good to see progress happening.
Alan, what are some of the electrical impedance? I'm sure there's lots of factors involved. You have a cable that stretches across your house to your stereo system, and you have to make sure you have the right, gauge of wire to properly power your speakers just 25 feet across your living room. I mean, how do they pull this off?
Right.
A 4,000 kilometer cable, this 700 kilometer cable. See that, Rosemary? I'm sticking to kilometers for the moment. I spoil you for the rest of the world. Alan, how do they engineer this so that they don't lose so much current? Is this just like the size of a tree trunk?
Yeah, it's going to be pretty massive to avoid the losses that would automatically occur here. So there's really two ways to transmit power today. High voltage AC, which is the way we've been doing since the early 1900s when Tesla came around. Tesla as in Tesla, the inventor, and Westinghouse started transformers and high voltage transmission lines. That's the simplest way. And then obviously the newest way is what we're doing on some of these offshore wind turbines, which is high voltage DC, which because we have the power electronics now, we can do that. So I think this cable is an AC cable. The issue, there's a couple issues you have to deal with here. Obviously loss, obviously voltage, obviously temperature, right? So you're probably using the ocean to cool the cable down a little bit. You can shove more energy into it. So it's kind of going to play a lot of different roles. And when you design something like that, if you look back in history of undersea cables, it hasn't gone very well for the first couple of generations, and they figure out how to design it. The hope is here, if we're going from the UK to Norway, that we obviously are implementing all those things that we've learned, but this is a new territory. It really is. And I think this is probably the first of many, but technology-wise, the concept's great. I think the implementation is yet to be determined. Hopefully it works, and I think the UK really wants this to work because they think they need it. And it just opens up a whole bunch of doors for the United Kingdom, which has now separated itself for the most part from the European Union. It needs partners, right? And it needs power partners in particular. You notice it didn't put a cable over to France. It's going up north to Norway. So there's a lot of geopolitical aspects of this too. It's not just creating power and sharing power, it's alliances. And so when these play out, the engineering is cool, but I think probably in these particular situations, it's about geopolitics.
Well, 2 points to that. Number one, maybe the next generation of supervillains will tap into other people's cables and steal it like you can steal, television cable. So stay tuned for that. Yeah. We might need James Bond in the future. But number two, is there any kind of redundancy for this? So obviously, if you have a gigantic cable that's powering thousands and thousands of homes and sending all this power, what happens if it just goes offline, something happens? Obviously these we reported on a story, months ago that one of the cables had, I don't know if the word's severed, but came disconnected. I mean, this is not it's not quick, just hey, John, just go turn it off, turn it on, plug it back in, like your router in your house. Is there any way to install redundancy, or does it just have to be super well built and just hope for the best?
Both, right? Because that situation where they had the broken cable or the exposed cable happened in my state on the shoreline, where it goes to Block Island, which is a place where they have 6 wind turbines. So they're not actually going very far. You can see the two shores. So it's kind of like Scotland to Northern Ireland. You can kind of see between the two. It's not that far, but they're having problems, right? And I think as we start grappling with more and more offshore, and we start talking about 15, 16. I see a lot of discussions about 20 megawatt machines at the moment. Man, the engineering going into those cables is massive. And yet you don't hear anything about the design of those cables, right? You hear all about the blades and the nacelles and the generators, but the cables, that's easy. No, it's not easy. It's extremely difficult to make those things and make them work properly. So there's a lot of work to go, I think.
Well, and going back to my supervillain question, this is a serious. We've talked about black swan events before, and a black swan event is just something that you could have never really seen coming, right? 9/11 here in the U.S., no one would have ever guessed terrorists would hijack planes and fly them into buildings, right? Is anyone thinking about protecting these cables? Say 10 years from now, again, there's, whether some bad actor country decides, hey, we want to put a lot of Europe off the grid. So they have a submarine attack that slowly deep in the ocean. They go sever a bunch of key arterial cables. Is anyone planning for that? Obviously, I know you don't. Neither of you know the answer to that, nor do I. But you wonder if anyone's planning for those kind of things, or if you're just assuming, no one would ever do that. But no one would have seen all these cyber attacks coming either 5 years ago, right? So it's our new
Right.
It's our new normal. And you wonder about some of this infrastructure, the fact that it is just hanging out at the bottom of the ocean. It's not like they can have, it's not like it's can be protected by guards. It's the bottom of the ocean. So you send a submarine down there and it's exposed. I don't know. Rosemary, what do you think?
And I think definitely it's too obvious that no one has thought of this, right? So you're going to have to plan your whole electricity system around the knowledge that at some point this is going to drop out without warning and may take a while to fix. So, I mean, sorry, I keep on hijacking the conversation back to the sun cable, but I know that the plan is that will supply, originally it was 20% of Singapore's power, but I was just on the website now, and now they're saying 15%. It seems like too much, it sounds instinctively like you can't have that huge chunk of your power coming from something that could drop out for months without warning. So they're going to need anyone that's relying on a large chunk of their electricity from a subsea cable is going to want to have a lot of redundancy and maybe a lot of storage. I'm not sure exactly how they'll do it, but for sure it's too obvious that it just didn't occur to anyone, and that they'll be just really surprised when it happens the first time.
Yeah, whether nefarious or not, like you said, you have to hedge your bet. And I think the pandemic with COVID was an interesting wake up for a lot of people financially, which is like, in the U.S. at least, and it's probably around the world, people say, well, get a good stable job and a paycheck. But if your one stable job pays all of your bills, and if you don't have a lot of money left over month to month, if you lose that job, you're in trouble financially really quick, right? And I think a lot of people learned that, where they have, a side hustle or a small second income, something to say, okay, if I get let go, if something unexpected happens, I still have X amount of income that I can live off of for a little while. And I think that was to your point about you don't want to power the entire country by one cable, because if that cable is compromised, you're in big trouble. Yeah, I mean, Alan, obviously it doesn't seem like there can be any physical barrier here to prevent this, but what's your take on it?
Well, it's exactly like what's happening in Europe right now with the Russian pipelines, right? That Russia is holding some significant part of Europe, Germany in particular, hostage. And you just don't want that situation. And Germany's obviously is trying to unwind that. I don't know if everybody saw the news, I think it was today or yesterday, where Russia would like to send oil their way, or natural gas, I forget which one it was, probably natural gas, to Germany through the new pipeline. And they wanted approval. Can we use this new pipeline? Let us use a new pipeline. And Germany's like, well, I'm not sure that's a great idea long term. Maybe we ought to wait a little bit. So there is so much to energy and how it plays into the world economic condition.
Yeah, it just, like you guys both said, it seems complicated, and having lots of different sources that can be flipped on and alliances, that all seems pretty critical to have that support network to keep everything up and running. So we're going to transition now to our interview with Morten Handberg, who is the chief blade specialist from Wind Power Lab. He's a mechanical engineer by trade, has worked in the past as a test and qualification engineer for Siemens Wind Power, and as a blade integrity specialist for Dong Energy, among others. So really knowledgeable guy. We're really excited to have him. So without further ado, we're going to take you to our conversation with Morten Handberg. Let's get down to it. So we want to talk to you a bunch today about blade maintenance. And prior to 2014, blades were sold kind of as this maintenance-free component. But this I think idea has changed a lot. And it seems like there's 4 big areas that really need to be considered if a company is going to try to maintain their blades long term, because they're not maintenance free, right? So can you speak a little bit to the kind of the 4 big components of blade maintenance?
Yeah, but also I think it's also important to understand that earlier blades were designed a lot more conservatively, so they had a much higher resilience towards erosion that we're going to dive into, and also fatigue. lightning would still have been an issue. But when the blade started to grow a lot longer, then some of the issues that we're dealing with today, they started to accelerate and become much more exposed, and also it needed to be taken into account. So that was why that earlier it was considered more of a maintenance free product. But if we look at what needs to go into a maintenance plan, then you need to know your blades. You need to know what kind of blade type you have, because they are not designed equally. There are different design modes out there that affect what kind of wear mechanisms you're looking at. And then you need to look into what kind of defects, what your defect areas are. And the key ones are erosion, lightning, and fatigue. So if you know those four things, and that ties into what kind of climate conditions you have, then you have a really good understanding about what kind of blade and what conditions you have, and that will build your maintenance plan.
Okay, so you kind of build things around erosion, fatigue, lightning, and climate. And of course, like you said, climate kind of interacts with all three of those. So when we talk about a maintenance plan, like we've talked about insurance a bunch on the show. I mean, is that something that, insurance companies are really pushing, or is this just like the industry as a whole has realized, hey, we need to do more proactively rather than just reacting when, we've got a major problem?
It's something that's being mentioned, but it's not something that they are actively saying that your premiums will get lower if you have a maintenance plan. But I think, again, as the blades, the larger turbines, they become, they have more years in operation, you start to see these defects coming again and again. Then at some point, I think that the insurance company will look more favorable to an owner who has a maintenance strategy that shows that they are proactively inspecting, doing repairs to reduce negative effects from fatigue and lightning. And it's kind of like, at some point it will be like, if you have a house and you don't lock the door, but you have a break-in that steal a bunch of stuff, the insurance company they will probably reimburse you for that. But when it happens 4, 5, 6, and 7 times, the same thing, they'll start to say, okay, if you don't lock your doors, then we're not covering it. And I think we will see the same things with blades and turbines, that if an insurance company can see that the owner or operator is simply not taking care of the asset, then their premiums will go up, or they'll simply remove the insurance and they'll have to find it in another place.
You mentioned the home inspection or the home insurance. And so this, to me, especially if assets are changing hands. So, if a wind farm is sold to a different operator, I assume they're going to do a lot of inspection. Are they going to start from scratch? I mean, it seems like that kind of situation, like a home inspection, but for the wind farm, for all the blades, would seem to make sense, as, like, again, you're selling this big asset and re-upping the insurance, all that sort of stuff, starting fresh. I mean, do you see that a lot? Is that kind of a decent analogy if assets are being sold?
No, that is very common. So, I mean, it's I would say I don't think it goes on without having some sort of inspection when the asset's changing hands, and it's both when it goes from one operator to another. There would be a due diligence of what is the condition of the asset. So they want to know what they're actually taking over, and do they need to do something when they're taking over the new asset. And the same with the insurance company. If the policy changes within the insurance company or from one insurance company to another, it's also very common practice to do a due diligence of it. And blades have not been the ones with the most focus in the past, but we see that it's actually something that is a high target on these surveys when they're being done, because there's a lot more knowledge now on how lightning, fatigue, and erosion can affect the assets, and that means a lot when an asset is being transferred.
Well, and especially today, we're talking about much bigger blades than in the past, right? So if it was a 40-meter blade, that's not going to be nearly as expensive as a 107-meter blade or something like that today, and obviously times 3. So I think it seems like the stakes are a lot higher for when these assets transfer hands. And this reminds me, like, I remember one of the first cars I bought as a high schooler. I just remember feeling at ease when we went to the seller and he's like, do you want my records of the oil changes? Like, he had changed the oil religiously every 3,000 miles. And, it made me feel at ease. Like, yeah, okay, well, this car has been well taken care of, even though it had higher mileage. And I think people probably want to see that same thing, especially when these are, obviously multi-million dollar transactions. So I think one of the things that we haven't talked much about on the show is blade fatigue. And I know that's something, you guys talk a lot about at Wind Power Lab. So what do people need to know about fatigue? Because obviously erosion gets a lot of press, lightning gets a lot of press. But tell us, give us an overview first of what we need to know about blade fatigue.
Well, it's a very, very broad area to start with. So I mean, we could start a PhD course right here, right now, on fatigue alone. But I'll try and cover the basics. So as you know, a blade is being continuously exposed to when the turbine rotates. It's experiencing fatigue loads because it switches between tension and compression continuously during the rotation. And what you can imagine is that this is the blade, and then it would continuously just bend upwards, and continuously in a lot of cycles. And each of these cycles adds to the total fatigue count, which is called rainflow count, where a certain amount of fatigue load will then add will reduce the blade's lifetime with X amount, with Y amount. And there is something called SN curves, where if you have a component that is experiencing a certain amount of loads at a certain amount of times, then it will fail. But if you increase that load, then the amount of lifetime will be reduced, not equal to the load increase, but exponential. So from 1 to 1.1 kilos, that 10% load increase can have just as a hypothetical 100% decrease in lifetime. So if a 1 kilo means 20 years of lifetime, then a 1.1 increase can actually then reduce that to 10 years. This is just hypothetical, but it kind of shows to the nature of how fatigue loads, how aggressive it can actually be if you just change those loads, because it has a really high impact. And that also ties into icing conditions. If you start to see icing loads, then if you're not controlling the turbine in the right way, either by curtailing or stopping it due to these ice loads, you can actually experience early life fatigue issues, because this ice mass is located at the tip of the blade, where it will add the most momentum to it. So that will have a very high effect on fatigue issues, and we'd actually see that we can tie ice buildup into actual fatigue damages.
Okay, so that's a pretty big reason to potentially have maybe some de-icing solution, whether it's, I mean, I know there's a lot of different ones on the market. Eologics, we had them on the show. They have an ice sensor. Do you recommend then how are they going to measure that so quickly where they can say, okay, we have enough ice where we definitely need to shut these down and get them cleaned off before we go again? Because you said like that 1% increase in fatigue could have a 10-fold decrease in lifetime. So it seems like the stakes are pretty high.
Again, it depends very much on what kind of blade type you have, because some blade types will have higher load capacity. Others will have a lower so that really depends on how conservative the blade is made and what control mechanism. So I would definitely argue that that control should be in place, and also load monitoring of the blades. And not all blades have that. So there will be some natural frequency measurement, but that will detect this change. But the big question is that too late? Have enough icing actually build up that will then increase these loads to reduce the lifetime of the blade.
So Morten, when we talk about fatigue, there's a number of different modes of fatigue. And as the blades have gotten longer, obviously they get heavier, and obviously they also get faster tip speeds. So just a lot more forces involved. What kind of fatigue failures are you seeing in the field right now?
So a lot of what we're seeing are longitudinal cracks along the trailing edge. That's a quite common one. We also see some trailing edge cracks closer to the tip, leading edge longitudinal cracks, and those are the most common one, very directly related to fatigue, because it works in the longitudinal direction of the blade. But the big thing is that if these fatigue cracks are not detected, they will then start to create radial or transverse cracks because a crack allows for degrees of freedom within the blade. And it's unintended degrees of freedom. So that would mean that the crack can move independently. And when it does that, then it actually just accelerates. And when it reaches a certain point where it can start to open and close, then you'll start to see cracks going perpendicular to the longitudinal crack. Often fatigue defects also develop because of imperfections in the blade. This is still a handcraft. They haven't been automatically produced yet. Yes, some use RTM processes to cast the blades, but all of the glass is still more or less handled or to a degree handled by people laying in the grass in the glass. So there is a risk of these. Most of them are then being detected by the QA personnel at the factory. They're actually quite good at this, but sometimes something slips through the cracks. And one of the critical ones is a wrinkle. And if you look at a piece of paper like this, if it's stretched out, this is a good laminate because the UD fibers they can hold a lot of tension and compression. So the laminate is working as it should. But then if it's folded like this, then when the blade is in operation and tries to this wrinkle here is experiencing tension and compression, it will try to stretch out, but because it's cast in, then it's stuck in place, and that means that it has very low load capacity, and then that will lead to a very early life fatigue development. And these can be, some of them are in the surface laminates, doesn't have a major effect. So if anyone goes after this podcast and detects a small fold in the surface of the laminate, doesn't mean that there is a critical issue. Because it's when it's inside the UDs that they become really structural, especially if they are transverse to the blade direction, then they are critical. But then often you can't see them, but you can see the effect of them. And that's also why I would always argue when you're doing inspections, do internal inspections, because fatigue damages, if they are structurally critical, they will often be visible from the inside first. When you see them from the outside, there is it doesn't mean that this is the case every time, but there is a high risk that then it's too late, and then you need to take the blade down, do a repair, maybe even replace it.
So inside the blade is a little bit of a new inspection technology, right? So we used to just put people on ropes and we would inspect the outside and we'd look for cracks and split trailing edges and those sort of things. But it can be very hard because the coatings on the blade can be very thick and may has been repainted once or twice, and so it's sort of hard to detect those beginning problems. So measuring inside, because there's no coatings, you can actually see a little bit more. What are the technologies used today to look inside a blade and try to see those structural issues? So
you can still send in a guy to inspect in the chambers, and he would go in and then look for any anomaly. And structural issues inside the blade is actually very, very, very easy to detect, because when you have a crack or you have a delamination, the coloring will change from olive green to milky white. Sometimes we see that then dry fibers are also being detected and categorized as fatigue defects. That's not necessarily the case, but if you see a polygonic shape inside your blades, it's very likely you have a delamination. And if you see an open tear with white sides and loose fibers sticking up, you have a major crack. That's so it's quite easy to find these on the inside, actually. That doesn't mean that you can see everything, because if it's subsurface or very close to the surface that started, you might not see it because of the light deflection, and you still have the coating on the outside. So it's easy to see the things that start on the inside of the blade, and that is the majority of the structural issues. We see that. So if you have something in the web or the box beam, the spar cap, or in the shell laminates, then it would be a very easy to detect. it would only be for the inner third of the blade. If you want to go further out, you would need a robot crawler or a camera that you can hoist down through the blade. But that's, unless we have a suspicion, that's really something I recommend, because all critical issues that we see and that are common, they're within the first third of the blade.
And why is that? And that's great you covered that, because I was actually just going to ask, like, what kind of tech do they need to do this inspection inside the blade? Because I know obviously they're getting bigger and bigger. We're now, some of these new blades, you can stand up and reach up and not touch the other side of it, but they get pretty narrow as they go. So why the first third only? Is that only where you detect these typically? And then what other technology do your techs need to take in there with them?
Well, I mean, you can use a drone that is suitable for internal inspections, or a guy, but they would reach more or less the same area. The guy, when he reaches the inner third, he would get into very confined space, and I've been there. It's not fun to get to
terrifying
past the inner third. But it's simply because, I mean, and even the inner third is still more than you need, because it's the blade root that is critical. It's the start of the web that's critical, and it's the transition zone, and then the shoulder area. That is where the majority of all the loads are. The high loads, they are centered around this area, because that's where you get the most. That is where you have the highest momentum, and it's also where the blade is transitioning the loads from the web back into the root and shell laminate. That's also why it's called the transition area. And so any imperfection or anywhere that will show in that area first. So if you have an issue on the blade, then that is the critical area. And the further out you get on the blade, the less load you'll have. And that doesn't mean you can't have fatigue damages. You certainly can, but often they would be less critical. So, because if you have a fatigue damage in the inner section of the blade, that can lead to a blade failure quite fast if you don't act on it and if you don't detect it.
Morten, what is the effect of fatigue on the adhesive joints, the bonded joints, not just the fiberglass structure composite there? Do the bonded joints also have fatigue limits and accelerated fatigue over time?
Yes. In most cases, we see that the adhesive joints are often stronger than the laminate. So it wouldn't be the adhesive joint that fails, it would be the surrounding laminate. When we see adhesive joint failure, then it's because of adhesive failure. It's actually quite rare that we see cohesive or fiber-tail failure as an effect on the adhesive joint. So that is the main problem. It's still a fatigue issue, but it's being guided by poor adhesion, so back to a manufacturing error. So the adhesive joints in itself, I'm not as worried about, unless you have missing adhesive, because we know that is an issue, or you have insufficient mechanical bonding between the adhesive and the shell or the web.
So when you walk up to a blade, and because Morten, you're sort of like a blade whisperer, right? So you've been around blades enough that you see all the variety of things that's happened to blades, and you know the different manufacturers, and you're just familiar with all the deficiencies and the intricacies of each one of them. So when you walk up to a blade, what are you looking for? And how fast can you say, hey, that blade has an issue, that one really doesn't? What is that like?
You see it when you walk into the blade, because again, these structural damages are very easy to detect, and the way you would recognize the failure is by looking at how the failure pattern is. So again, if you see separation between the web and the shell in the adhesive joint, then you would look at an adhesive failure. If you look at a transverse crack over the shell, you would look at a wrinkle. So a lot of these damages, because we've seen so many things over the years, we instinctively almost know that this is actually this is the reason why. If we see longitudinal cracks, then we would go into the logs and look at how the blade has been operated. And if we see long stretches of parallel lines, we would look for emergency stops. So there's a lot of factors there. There's a whole guideline that we're actually building around damage, how the damage appearance is, and how that relates into the fatigue damages. So I don't know if any of you are mushroom hunters or ever try to open a mushroom book, but if you do, you would get this sort of guide that, okay, does it have a red hat? Is it a white stock? We're trying to do the same thing around blade damages, essentially, because it is a multi-layer identification that we're doing. And we start out by looking at what kind of blade type do we have, how is it structured, what kind of failure modes can we then have because of is it a pull-through beam, is it a dual shear web, is it structural versus non-structural shells, all of that. And when you know the major OEMs and you know the design, you can also then start to derive what kind of failure modes that are relevant.
I like the analogy because I think eating fiberglass is probably just as deadly as eating random mushrooms in the forest.
Recommend it.
Yeah, you can't just eat more than a handful of random mushrooms in the forest where you just get a poisonous one and that's the end of you. So it's a great analogy.
So, Morten, have you ever walked into a facility, seen a blade, and said, shut that turbine down right now? Because it just...
Yes, I used to work as an operational engineer for a major utility. Yeah. And then I would have inspections coming in, and then I would look at the inspection reports, and then there was this damage is around this critical area here. It's longitudinal or transverse. They would call up the site manager and say we need to shut the 044 down, and then the site manager would then respond to me, okay, this is that many grams per day. Are you sure? So I would always get the costs just to verify how certain I actually was, and. So I have done that a few times. Said that, okay, shut this down right now.
Wow.
Yeah.
And are most of these
that's amazing? And
are most of these structural damages that you'll find, are they mostly repairable, or I mean, how far along do they have to get before it's like, hey, we just need a new blade?
I mean, there is a point in time when the repair exceeds the cost of the blade, essentially, because
totaled, so to speak.
Whenever you need to repair beam laminate or a structural shell, then you need to have an overlap between each layer. And that would mean that a crack, that if it goes through, or delamation, if it goes through enough layers, then in some cases you would use 50 millimeters per layer in each side. So that would mean that you would actually extend it by 100 millimeters for each layer.
Right.
And if you have that to do that for 20 or 30 or 40 layers, some blades even have 50 layers if we're back to some of the older conservatives, then a relatively small damage would actually require a repair that could be 4 or 5 or 6 meters long, even if it's only in a relatively small area. But that is because of the direction of the crack and the number of layers that it's impacting. And then we start to look into, okay, the cost and the downtime of the turbine. Does that really correspond to the value of this blade? But then when you start to go into that direction, then does the new blade, will that fit? And do you then need 3 blades? And there are cases where the repair is simply too risky because it's affecting too large an area of the structural parts of the blade, that the risk of the repair being more problematic than the damage itself, then you wouldn't repair it. Then you would just say, okay, we need to replace this. There is no way.
Wow.
I've also seen one where a crane moved a bit too close to the turbine and they didn't shut down the turbine. And then 1, 2, 3, and then all 3 blades had the tip smashed.
Wow.
So there were replacements.
Yikes. I just wish there were videos of all these things. I don't know.
Yeah.
I keep pushing that on every episode. Like, let's get video everywhere. So when these incredible calamities happen, we can see them.
I mean, if you dive enough into it, I mean, recently you guys had an episode where you discussed a train running through a blade.
Yeah.
So
right.
A lot of different things happens to the blade out there. I blade blades out there.
Yeah. So lucky no one was hurt in that one. Jeez.
Oh yes.
That was crazy.
Oh.
That's I completely agree.
Yeah. So say there's an operator listening to this podcast and like, okay, we should check out the fatigue of our blades. I mean, how often does someone need to inspect this? I mean, is there any warning signs that they would see from the ground or see from a monitoring system? I mean, is everyone just need to do this every certain amount of years, or what do you recommend?
Well, I always recommend doing a subset every year because inspecting all blades every year is just a huge cost factor, especially when we're talking about offshore. And onshore, if you're in a remote location or your turbines are spread out, then it's just a huge cost on you to do everything. So what I normally recommend is to do a subset. It can be 10, it can be 20%, so that over a period you actually get through your entire wind farm. And that serves several purposes. If we start by just looking at fatigue, that means that if you, within that population, then see a certain amount of fatigue damages of the same type starting to develop, then you know that this would be representative of the remaining part of the wind farm. So let's say you see one damage, one fatigue damage. That doesn't really mean a lot. And if you then go in and look at what is the root cause of it, is it fatigue related, is it production related, or is it a bird that hit the turbine, the blade? That will tell you a lot about, okay, do we need to expand this? So I would always set up trigger events with my inspection subset and say that if that is exceeded, then I need to do a full 100% inspection. So that's normally the way I would approach it. So don't just do 20% every year or 10%. Do the 10 or 20 and then look at what did I actually find and what did I learn? What does this tell me about the current condition of my wind farm?
And is this? I assume this is something they'd probably do at the same time as like a leading edge erosion inspection. I mean, do they want to? How many of these services would they want to combine all at once just to sort of maximize downtime?
So erosion you can do at the same time as fatigue. I mean, fatigue you would also do an equal subset on the inside, but erosion you really don't need to do a lot because erosion is erosion is easy to handle compared to the others because it's predictable. Because if you look at 10% of your wind farm, even if you almost only have 10 turbines, and that means one turbine, if you can see a certain amount of erosion on that turbine, then assuming that they've been repaired at the same time, following the same processes, the remaining 9, they will look exactly the same.
Yeah.
So you don't need to do a lot on erosion. And there we would normally recommend follow the erosion from the beginning. And then when you start to see exposed laminate, then do a repair and select the right leading edge repair solution. But it can be tied into the fatigue inspection. You don't need to do anything special.
And then I know you're passionate about educating people and helping operators like get their own staff up to speed to be able to do a lot of these themselves. What does an operator need to? Do they need to always outsource someone from this? I mean, can they train their staff to do some of these inspections, or how can they develop a maintenance plan on their own? Because we've talked about before in previous conversations with you that not every wind farm is going to be big enough to have a maintenance plan, right? Some are going to be small, but they might say, "Hey, this is a good thing we should do in the future." So, how would you recommend that smaller wind farms or larger? If they don't have a maintenance plan for their blades, that they go about getting one and getting their staff trained.
They can do something really simple. If you're a small owner, a farmer having 10 turbines, then if you then do annual or biannual inspection of a subset, and then look at what is the current condition, maybe then get an expert to do it. Then you would be in good shape anyway, because then you would get the accurate results and understanding of what is actually going on my wind farm. If you're a larger operator and you need to look at what is the conditions across your portfolio and plan major campaigns, then it makes a lot more sense to then go in and then do an actual maintenance strategy and plan out when do I need to schedule inspections, when do I need to schedule repairs, what kind of OPEX cost am I looking at from fatigue, lightning, and erosion over the lifetime of the turbine of the wind farm. And you can do a lot of this if you know some of the history of your wind turbines. Then you can use that to make trend analysis and then make some pretty good predictions. You won't necessarily hit the mark, but you'll be better off than handling everything on an ad hoc basis. So for a larger operator, if you don't have a maintenance plan, then you don't have an overview what your OPEX cost would be. So that is the benefit by doing it in a more structured way. So therefore, I would recommend the differentiation between large and small operators.
So Morten, one of the newer technologies on the marketplace is the ping monitoring system, which is an acoustic sensor that actually mounts to the wind turbine base.
Yeah.
Are some of these fatigue cracks detectable because they make noise, or leading edges or trailing edges that have split? Do they make enough noise that ping can pick those things up?
I think for a lot of defects, yes, they would have a really good chance because they change the airflow over the blade, because it changes how the blade operate, how the blade acts. Again, back to the degrees of freedom. So that would definitely be detectable. And but it's always difficult, and I can make an analogy because you try to dive a lot into these from the load sensors, and the load sensors, they can pick up a lot of fatigue cracks as well. They can't tell you where they are, and ping have sort of the same issue, but at least they can tell you that you have a fatigue crack. But it doesn't mean that you have a golden ticket, because I've tried digging through, finding a 5-meter long crack at the tip of my blade, looking at the natural frequencies, and there was no difference. Nothing could be picked up.
Wow.
Yeah.
Wow.
The ping sensor would, on the other hand, have an easy way to detect that, because it was quite open, the blade. So there would have been, it would have been very easy. So I think it's about also looking at things being used in combination, because I think especially for internal defects, unless you also have an internal acoustic sensor, then those defects would not be possible to pick up with an external sensor. So again, I think we're back to understanding what kind of problems you actually have on your wind farm, and then designing what kind of monitoring system you have in accordance with that, and not just say that one fits all. I rarely think that is the way forward.
Yeah, that's a good perspective. It seems like it's just so complicated, and like you said, for so many different areas of the blade and so many different things are happening. That makes sense. So Morten, one of the cool things you're doing is you're doing a 2-day course for operators to help educate them about blades, about maintenance, all that stuff. Can you talk a little bit about what you're doing? I think that's pretty interesting. I think people in the industry need to know about it.
Yes. So I'm starting to make these courses, especially tailored to operators, but also to loss adjusters or subject matter experts or independent companies that want to know a bit more about the blades and what's going on behind the blades. And there we look a lot at what kind of defects do we have out there, and then back to how do we accurately identify them by showcasing where on the blade would you find leading edge erosion, where would you see delaminations, where are wrong lighting attachments common, and where would you find voids, chipping, peeling, and so on and so forth, and also dive into what is causing these different defects, because when we look at, for instance, voids, peeling, chipping, they're all called surface defects. They're all being repaired in the same way, but they are very different in why they actually are there on the blade. So voids comes from subsurface air inclusions in the coating or the filler. Peeling comes from it's called workmanship, but it can be both materials, can also be insufficient cleaning or grinding that simply have limited the adherence between the filler and the paint, and then will just peel off again. And then we have chipping. That is an added effect to voids or erosion where you already have an exposed area, and then due to environmental wear, this defect will continue to chip off the void or the erosion and accelerate this defect. So they're all considered surface defects, and often they are being mistaken with each other. But we try to dive into what actually causes these and how do you differentiate between them. And we do the same for cracks, delaminations, and all sorts of defects, both externally and internally. And we also go into the more operational part. So what do you need to consider around your environmental conditions that will help you identify what kind of leading edge erosion solution you should use and where you need leading edge erosion protection. So that is just a small snippet of what I dive into. And I can talk for a lot of hours on this subject here. So.
And is that something people can sign up for on the web, or how do they get in touch with you about that if they're interested?
So they can contact me or my colleagues directly, or they can also contact us through our website, and then request some additional information about our training courses.
Well, that's awesome. So is there anywhere else that people can follow up with you and Wind Power Lab on the web?
So we have a LinkedIn page where we regularly update on our activities and where we are active and what services that we're focusing on and promoting. We also have a website where you can learn a lot about our our assessment and repair recommendation services, our root cause analysis, and also our training courses. So there, whatever problem you would have within blades, then you can go and find a solution and contact us. And if you don't know if you have a problem but you don't know what service that would fit it, also just contact us and let's have a talk about it. That's always an option. We're more than happy to talk to the operators and the service providers within the industry, and also just trying to understand the problems they have from their perspective, and then see if we have a service that fit them, or otherwise just give them a friendly advice.
Awesome. Well, Morten, thank you so much for coming on the show. We really appreciate it.
Likewise, it was really good to be here.
All right. Well, again, we want to thank our guest, Morten Handberg, for coming on talking with us about blade fatigue issues. Again, be sure to follow up with him in the show notes of this podcast. You can easily find links to get in touch with him personally and the company. And again, what they're doing is cool with the educational aspect of it. Again, with all the big OEMs keeping a lot of their trade secrets close to the vest, which is understandable. There's not as much knowledge flowing around. So if you need to learn more about how to maintain your assets, or you just want to learn more about what they know, then definitely check them out and send them a message through the show notes below. So moving on, Vestas is installing their V236 15 megawatt wind turbine prototype that was announced earlier this year at the Austerlid National Test Center in Denmark. So, and this is kind of sort of coinciding with a good article on the BBC about, just how fast these wind turbines are getting pushed bigger and bigger, right? So, Mingyang, Vestas, GE, Siemens Gamesa, they've all put out bigger turbines this year. The HAL 8X, the 14222, here the Vestas 15 megawatt version. And one of their higher ups, Ariel Nass, who's the head of offshore product market strategy at Vestas. Here's a quick quote from her. She said, it's happening quicker than we would wish. In a sense, we need to make sure it's a sustainable race for everyone in the industry, referring to the race for bigger megawatt outputs. And so, Rosemary, I'll throw this to you first. I mean, she's pointing out the need for bigger harbors, bigger equipment, bigger jack-up vessels, installation vessels, all this stuff. And that it might be a little bit advantageous, it sounds like, to slow down a bit and let some of the infrastructure catch up.
Yeah, I thought it was really weird that, Vestas are one of the key participants in this race to get bigger wind turbines, and then we have someone from the company saying that it's against their will. It doesn't really. I don't know. It's not the best marketing maybe for their new huge wind turbine, and it doesn't give me a lot of confidence that the company is really behind the strategy. So I found that part of it really strange. And I also do think that that's the nature of participating in a competitive market, that whoever can supply what the customers want the fastest is going to have a competitive advantage. So I agree, and it's definitely very hard as an engineer for these companies. And every time you would get another announcement like this of a new huge longer blade or some other massive technology shake-up, engineers would all be rolling their eyes, complaining, and talking about it in the canteen. But at the same time, that that's your job, right? To make the best wind turbine that is what customers want. So it's uncomfortable, but you become an engineer because you want to solve problems, right? You don't become an engineer because you want to keep on doing everything the same for a long time. So, that's most engineers, or a lot of engineers, do that anyway. Some maybe just want a cushy job, but it's not as fun.
Well, I kind of read this article and wondered if it's kind of like, you have two boxers in the ring and they're both like battling it out. And then they both kind of look at each other and they're like, do we want to keep going? Like, we've already gone 10 rounds. Like, do you just want to call it a draw now? You know what I mean? Like, that was kind of how I read it, because you need one of you to like sort of extend that olive branch to say like, we've gone hard enough. Maybe we can back off just a little bit and like take a breather. I don't know, Alan, what's your perspective on this?
Well, I think they're getting driven by forces outside of Europe, actually. In the United States, I think what's happening is the Chinese and Goldwind and some others are really pushing the envelope, trying to gain market share. And in that competitive environment, I don't even know what to call it competitive in a sense, because I feel like there's the EU and the United States are going to be screaming about dumping like there was with steel a couple of years ago, that the Chinese offerings are going to be so low price or so much below what the market would typically provide, that the GEs and Vestas and everybody else are really going to start complaining. The problem they're in right now is that they have to. They don't really have a choice. So as China produces bigger wind turbines, they're forced to produce bigger wind turbines. The customers are clamoring for them. And what happens in those conference rooms is a Vestas walks in and pitches brand new wind turbine concept, because they don't even have any hardware at the time. And so we can get to 16 megawatts, and the customer goes, that's awesome, but my Chinese provider can do it for half the price you can. So guess what? I'm going to choose a Chinese provider. And that's where I think the real disconnect starts to happen, is the customer base and the European and U.S. manufacturers are really getting into a bind here, and something's got to give. In the U.S., it's probably the United States is going to just outlaw certain types of Chinese wind turbines. I think that will happen. I think that'll happen in Europe at some point too. So they'll just take it off the marketplace so the Vestases and the Siemens Gamesas can be profitable, because otherwise I think they're in a world of hurt competitively.
Yes, I just wanted to add the new Vestas wind turbine that they've announced. They're installing the prototype, 15 megawatt prototype in Østerild. The cool thing about that is it's actually a test wind farm that I visited in my first ever YouTube video. So I think the coolest part of this announcement is that this is open to the public. So anyone who is a wind turbine fan could actually show up and watch them install it, and and check it out afterwards. I mean, it'll be around for a long time. So, I mean, from a safe distance, I don't think they're going to let you, on the construction site, but that's what piqued my interest when I saw this announcement. I'm like, oh, I gotta get back to Denmark so I can watch the installation.
Yeah, I picture like people carving their names into the bottom of like a tree trunk, like Dan loves renewable energy in the bottom of the tower. But no, that's pretty cool if it's open to the public. Well, we expect to see a full scoop on your YouTube channel.
Yeah, I just gotta get back over.
Get your drones out, get everything going. Yeah. Mm-hmm. So finally on the docket today, Orbital Marine, which is the manufacturer of the Orbital O2, which is the 2 megawatt. Very cool. I'm impressed with it. Tidal power generator that they launched earlier this year. They're heading a consortium trying to essentially get to a floating tidal energy. This is a quote: floating tidal energy, wind generation, grid export, battery storage, and green hydrogen production system. So that's a lot of things. Rosemary, is that a little ambitious, or do you think this is something that could come to fruition?
Well, I mean, it's definitely ambitious, and I don't know if it could come to fruition. I don't know if I would want to bet on the likelihood of that happening. It's not like this is the first time that anybody has planned, some multi-renewable energy hub that includes ocean energy. I think there's also one that's been announced recently in Australia that uses wave power from Bombora. So I mean, it's good to see some continuing interest in ocean energy. This one's Tidal, and I think there's still so much potential left in the ocean that we haven't figured out how to tap. One thing I noticed about this is it's a big device. It's 2 megawatts, right? That's big for Tidal. I tend to think that in the ocean, especially with wave energy, companies have gone too big too fast, and you often see them run out of money before they have managed to actually test the feasibility of their technology. You really often see some, like just some regular maintenance things, or the cable is breaking, or, some other component that could be easily redesigned, broke, they ran out of money, and it all ended. And I think we've seen dozens of examples of of that over the years. Whereas if you'd seen, one company try a dozen times, you would have a mature technology by now. So I'm a little bit interested in that aspect of it, but let's hope that they've got, one time when I did a video, I interviewed a couple of wave energy researchers, and they said the most important thing for a wave energy project is that you have patient money from your investors. And so I hope that this project has patient money so that they can overcome those little problems that you have in technology development. I mean, you're always going to have failures and surprises. That's the whole point of trying it out for the first time. So I hope they've got the money to ride that out and, finally get this to go into the mainstream, because that would be really cool and a really good addition to, the renewable energy system.
It's still a lot of development to go. And I think that if they can get on it in the next 2 years, I think they got a chance to break over that wave, so to speak, and kind of ride some of the financial positive upsides of it. But if not, it most likely will be dead, because, as we just talked about, as wind turbines get bigger and bigger and bigger, Tidal just gets smaller and smaller and smaller as a player.
Well, that's going to do it for today's episode of the Uptime Wind Energy Podcast. Want to thank again our guest, Morten Handberg from Wind Power Lab. Again, follow up with him in the show notes of this podcast. Be sure to subscribe wherever you listen on iTunes, Spotify, Stitcher, YouTube, and leave us a review. It always helps the show grow. Share it with a friend, and we will see you here next week on Uptime. Wait 1 second. Let me pitch the thing. And be sure to subscribe to Uptime Tech News in the show notes of this podcast, along with Rosemary's YouTube channel on renewable energy. We will see you next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.